Okay, hello. Welcome to the second sample problem for chapter section 16.1. We've got this problem up here that says a 100-gram cup of water at 5 degrees Celsius. We're going to assume that the 100 grams is water. Don't worry about the cup, just the water. That's the mass of the water in there. At 5 degrees Celsius is heated using 8.13 kilojoules. How hot will the water get? In other words, what's the final temperature? They're going to tell us that C, the specific heat capacity, oops, I did that. I'm going to go ahead and get rid of that. The specific heat capacity for water is 4.18 joules per gram degree Celsius. Okay, so we're going to use our equation again, our equation that we're going for heat. Oh, you know what? Let me go ahead and undo that and get back to black again. We'll use the colors for other stuff. Q is equal to M times C times delta T. Okay. And if we can figure out what the delta T is, we can figure out how much the temperature changes, then we can figure out what the how much the temperature changes. Starts at 5, whatever the temperature changes, then we'll just go up from 5. Right, so that's going to be our plan for this one. We're given a Q actually. We are given, go ahead and put this in green here. We are given 8.13 kilojoules. It's heated using 8.13 kilojoules. It doesn't say that was how much heat, although it says heated, but the key here is the 8.13 kilojoules. So we have heat Q. We have a mass. The 100 grams right here is a mass, and we're given the C right here. So really, we have 3 of the 4 variables. We can solve for the 4th. So let's go ahead and do that. Now, what I'm going to do here is I'm going to solve for delta T first, and then I'm going to plug in. We could plug in right now and plug the Q in here, 8.13 kilojoules, plug in the mass here, plug in the C here, and then solve for it. But it seems to be less messy to move letters around first. That way we just have to cross out letters. So if we want to solve for delta T, this is what we're going to do. Q equals to M times C times delta T. We want delta T by itself. Whether it be on the left or the right, doesn't matter. Which means that in order to get delta T by itself, we need to get rid of the M and the C. So first let's get rid of the M by dividing by M. Okay, that way they cancel. But since we divided on the left, we have to divide on the right. So I'm going to go ahead and put the dividing on the left also, I should say. Now we just need to get rid of the C. And since C is being multiplied by delta T, we need to divide by C so that they cancel. And since we divided the right side by C, we need to divide the left side by C. And by doing that, now these guys are by themselves, and now we have our delta T by itself. Okay, and we can rewrite that delta T is equal to Q divided by M times C. Okay. So all we need to do is plug the numbers in, our Q here, our M, and our C. Now one thing I want you to notice is that the Q is given to you in kilojoules. 8.13 kilojoules in the upper right corner of the problem there. And C, specific heat, let me go ahead and make a point of this, is given to us in units of joules per gram degree Celsius, not kilojoules. Kilojoules and joules do not cancel out. So we need to cancel out we need to make sure that these are both in the same units. And I think the easiest thing to do is to convert the kilojoules to joules. And we're going to go ahead and do that. So our 8.13 kilojoules, we're going to go ahead and convert those. Every kilojoule is 1,000 joules, right? I think with kilo is 1,000th base units. So 1 kilojoule is 1,000 joules. That means this time we're multiplying by 1,000. And so 8.13 kilojoules cancel, leaves us with 8,130 joules. Now I can use this number right here in our problem, and that's the number we're going to plug in. So our delta T here, our change in temperature, is going to be Q, 8,130 joules, divided by the mass, which is 100 grams, right from the problem, times C. The C is 4.18 joules per gram degrees Celsius. And once again, our units are going to start canceling out. You can see even before we do the calculations, the joules here cancel out with the joules here. In the denominator, grams are twice, but once it's in the numerator here, once is in the denominator of the unit. So the grams here cancel with the grams here, leaving us with 1 over degrees Celsius for our units here. But since it's denominator, it's going to go to the numerator, and we've been through this before, right? The denominator of the denominator ends up in the numerator. So let's take care of the numbers, and we'll plug in the units here first. So we take 8130 divided by 100, and then divided again by 4.18. Now, you could do it a different way. You can go ahead and take the 100 multiplied by 4.18, that gives you 418. Then you can take 8130 divided by that 418. That'll give you the same answer, right? So one way or the other, that is correct. All right, so that's going to give us an answer of 19.45. So 19.5, let's do 5. And it's going to be degrees Celsius, right? Once again, this is 1 over degrees Celsius, but that's in the denominator. So in order to get rid of the degrees Celsius at the bottom of the denominator, we multiply to the numerator of the denominator to cancel them out here. But if we multiply to the numerator of the denominator, we also have to apply the numerator of the numerator, which is what ends up here. And there's our answer, at least. The answer for delta T, change in temperature, right? All right, now the question was how hot will it get, implying a final temperature. This was just the change in temperature, how much it increased. So we know that delta T, and this is our delta T, is equal to final temperature minus initial temperature. So what I can do is I can plug it in here and go, okay, well, 19.5 degrees Celsius is our temperature change. And that's going to be equal to the final temperature minus the initial temperature. And the initial temperature, the temperature to start off at was minus 5 degrees Celsius. So in order to find what the final temperature is, I add 5 degrees Celsius to both sides. All right, add 5 degrees Celsius to both sides. And when I do that, I get now that these guys cancel right here, and that my final temperature is 19.5 plus 5 is 24.5 degrees Celsius. And that is my overall answer. Okay? And so once again, that was just using our Q is equal to M times C times delta T equation in order to solve a problem like this. Last time we solved for what the Q was. This time we got the Q, and we were looking for a temperature. We were given a beginning temperature, and basically we were looking for the delta T. Okay. All right. So I hope that was clear as to how we went about doing that. Whenever you're given a problem with this, you've got to think, okay, I have 4 variables in my equation here. If they give me 3 of those 4, I can solve for the 4th one. In this case, as we saw, you were given Q, you were given M, and you were given C, and you can solve for delta T. All right, one more problem to do. The other one is a little bit harder, but not all that much harder. So I'll put on a separate video. Okay.